In this section of work, we're going to be looking at assembly drawings. So up to now, everything we've been drawing has been a single part, like this rubber or this ruler. It's made out of one piece of material. What happens when we have to draw something that's made out of multiple parts? Now this little camera case is made out of lots of different parts. So we can see it's got a clip that's got two parts in it. It's got the back, which is on a hinge. It's got a seal around that hinge. It's got a little rubber thing there, and the hinge itself is a pin going through. We've got a ring here with screws. This is a spring-loaded button. There's another one there. So you can see there's multiple parts. Now when we do a CAD model of this component, this assembly, we don't want to make everything the same, but it's not even made out of the same material. This is metal, that's clear plastic, and that's black plastic. And then here we've got steel screws again, so and a rubber seal and little rubber bump strips. So it's not even the same material. So we don't want to model them or draw them as the same as one thing. We want to draw separate parts and then join them together. So that's where assembly drawings come in. So an assembly drawing is a drawing that shows an assembly, something like this, with all the parts in their position. So we would have it probably draw this in its closed condition like that. And we draw all the views. Okay, so in addition to that, we would show what each part is. So, and we would have a list of those parts on the drawing, and then what we call balloon numbers. So let me show you a good example. There's a really nice assembly drawing shown here on page 81 in your textbook. So all the elements of an assembly drawing are very nicely reflected on this drawing. Right, here is an assembly view. As you can see, an assembly drawing can have orthographic views, isometric views. They can even be sections. So here you see the different parts are cut through and sectioned, but each different part is sectioned differently. It's also shown in the assembled condition, so they're all fitting together. So that is the assembly drawing. Coupled with assembly drawing, we have balloon numbers. Okay, balloon, they're normally just circles with numbers in them, pointing either with an arrow, as you see there, or with the dot on the end of it to indicate which part is which number. In conjunction with that, we have a table which has a parts list on it. The part number or item number, we sometimes call it, because very often a component will have a manufacturing part number, and that is different from the item number on the drawing. So we numbered here from 1 up to 6, and we then reference those numbers on the table. On one column, the next column would be the name of the part. So item 1 is the base. So there we can see 1's pointing to the base. So this is the base. And you can see the hatching goes through on the top. So that part is the same as this part and is part of the base. Item number 2 over here is the shaft. The material is even shown. So there's a column down here which is showing cast iron, EN8, steel, cast steel, bronze, key steel, mild steel. And then in the last column we have the quantity. We can put quantity, or we can number of. So in this case there's one of each. So if we had, like in the case of my camera case, we've got 6, 1, 2, 3, 4, 5, 6 screws holding this together. And in all likelihood that button is the same, and the spring inside is the same as well. So we would have that screw listed once, and we'd have quantity 6. So that allows you to, then you'd have a few balloon numbers showing all of the parts that are number 6. So you can duplicate, or you can summarize on this parts list into one line a whole lot of parts that are exactly the same. All right, so what else do we have on an assembly drawing? It's also called a working drawing. You'll notice that there's no dimensions on an assembly drawing, and that is because each one of these parts will have its own part drawing with detailed dimensions and tolerances as we've taught you how to do. But what we will have is a border and a title block. We have orthographic projection, and this is first angle. We will have who drew it, when they drew it, the title, the scale, the units. Maybe there's a logo from the company, etc. All right, so this is a good example of a assembly drawing, and it looks slightly different to the drawings we've been doing up to now. So one of the examples you're going to do is you're given all of these parts, and each one is a part on its own, and you are told then to assemble it together. You're not told exactly how it goes, but in this case it's quite easy to figure out. So what you have to do when you're assembling different parts and you don't know how it looks when it's assembled, you have to look at this and you see that plate, for example, number 1, frame plate. There's 2 of them. So it looks like that they go on either side of something. There's 2 of them. There's a hook block, number 2, which is this one. So there's a single one of them, and there's a 50 diameter hole over there. And then there's a cable wheel. There's 2 of those. There's 2 of those cable wheels. And then there's bushings, which are number 4. And there's 2 of those bushes. You see it's 38 on the outside, which just happens to be the same size as the hole in this bush, in this cable wheel. The inside is 30. So yeah, that would be where the bolt or the shaft goes through. So here you can see the outside of the shaft is 30 millimeters. So that looks like it will fit nicely through there. And how many shafts are there? There's 3 shafts, and there happen to be 3 holes here. So the outside is 20, and those holes are all 20. 20, 20, 20. So those 2 ends will go through the plate on either side. So you can see there's a shaft in each position. The plates move together on the shaft. They stop on that shoulder. In the middle, you'll get a bush on the 2 top ones. And the hook doesn't have a bush because that hole 30 is the same size as this diameter. So there's no bush on the center point there. So we can see pretty easily that we've got 2 plates that go on either side, 3 pins that go through their shafts. The bushes goes on the shafts for the wheels that are spinning, and those wheels or cable wheels, they'll fit either point, and then the hook goes there. So we can figure it out pretty easily. There's some nuts. The nuts have to bolt everything together. So how many nuts are there? There's 6. 1, 2, 3. So there's 1 on either side. Alright, so sometimes you're going to get given the parts and you're going to have to figure out how does this assemble together. And you have to do the drawing. Alright, so once again, to summarize our assembly drawing, it doesn't have dimensions, although sometimes you do put oval dimensions, but it's not a requirement. You can have sectioning. You will have everything assembled. You will have a list of the parts as item numbers. You will list them on your table. You'll give descriptions, material, and quantity. There may be more than this in your table, but that is the minimum. Item, description, part, material, and quantity is the bare minimum. Okay, so the purpose of an assembly drawing would be to show how everything fits together. So here it would be the model answer for that one I've just shown you, where you had to do a section view through the full assembly, showing everything in position so you can see how it all goes together. And there's the parts list with everything there. Alright, so there's a whole lot of sample questions and test questions, and it's important that you go and do your exercises so that you practice doing these assembly drawings and practice figuring out how these assemblies go together. All right, and remember that when it comes to the project, you're going to be doing a whole lot of different drawings. You're going to be doing part drawings for all of the components in your assemblies for your project. You're going to be doing assembly drawings as we've shown here, an isometric view with 3 views. You're going to be doing orthographic and isometric views of the assembly. And on the assemblies, you must remember to put balloon numbers and your parts lists. All right, so other than that, the same rules apply to assembly drawings. When it comes to projection, when it comes to line styles, hatching, everything else is exactly the same. All the rules apply. The only difference is you don't need a lot of dimensions, because that's not the purpose of the drawing. And you've got to remember to itemize everything. So typically in an engineering context, you would have a package of drawings for a machine, which would have an assembly drawing showing how the whole thing fits together, as you see it there. Each one of these would have its own drawing, which you could go and reference, and would have these item numbers or part numbers as the part number of that drawing, so that you could say, okay, what does the base look like? You see it's number 1, and you go and look for drawing number 1. You open it up and you'll see all the dimensions. So each one will be referenced in that way. All right, that's all for this section.